Hey, my name is Kyle Tucker, and this is my final programming languages presentation on the awk scripting language. I'm 25, married, and have two kids, and live in Gainesville. Sorry, guys, but I do bleed orange and blue, even after the season. I'm a graphic designer and web developer for the ASMBS, a nonprofit educational organization for medical professionals in bariatric surgery field. Um, I'm in pursuit of this degree in computer science not because I don't like what I do, because graphic design is one of my greatest passions, but because I love what I do. And I want to be able to really give 360-degree expertise in the field of user experience, be that in web and mobile applications, operating systems, up and coming technology like augmented reality or 3D projection, automobile design, whatever. Um, I feel like there's still a lot of areas where form and function still don't quite see eye to eye. And my professional goal is to be able to bridge that gap in whatever my bubble may be. Um, Outside my professional educational life, I'm a pretty simple dude. I love being a family man and being able to play with my kids and enjoy life through my family. On top of that, I like just about any show they put on History Channel. Don't ever try to make me do anything on Saturday during Gator football. Um, and I'll take a good steak, a cigar, and a great glass of bourbon any day of the week. Alright, so let's talk about awk. And just right off the bat, I'm going to go ahead and talk about the name, because, yeah, it's kind of weird. awk is, in fact, an acronym for the three original designers of the language, Alfred Aho, Peter Weinberger, and Brian Kernighan. So you see the AWK there. So what is awk? It is a data-driven interpreted language. Data-driven meaning you specify the data you want to work with and what do you want to do with it, versus a more procedural language where it's more difficult to describe the data that you're looking for. Its primary focus has always been text processing. Search data for a pattern, perform actions if or when matches to that pattern are found. Still, it's a very powerful language with support for subroutines and variables and input and output, so it can in fact be used for large and powerful programs. The original language and its interpreting utility awk were developed in 1977 at Bell Labs by the three guys I mentioned before. The documentation of the original is pretty poor, so there's not a lot of information specifically about that version. But the last of the three, Brian Kernighan, kept working on it, and in 1985, 8 years after the original, released a brand new version of awk, which was dubbed New Awk, or Knock for short. It's more lovingly referred to as the one true awk, because it was the only one of the many awk forks that was developed by one of the founders. The term was actually coined in their book, The Awk Programming Language. That's the original book that described language, which, yeah, the first book on language wasn't produced until after the new version of the language was out. It was published in, I believe, 1988, which is 11 years after awk's original release. Anyway, this one true awk included some big improvements like support for user-defined functions, which we'll talk about in a minute, and computed or dynamic regular expressions. GNU awk, or GAWK, was written in 1986, has been maintained by Arnold Robbins, who also wrote the user's guide for the GNU implementation, which was one of my primary research sources. GAWK introduced network access, internationalization, localization, and language-level debugging to awk. awk is very widely distributed, especially with Unix. It's a required utility in the single Unix specification and in the Linux standard base specification, which almost all Linux distributions come with Gawk, since they're generally new systems. Besides that, there's a port of either Gawk or another version of Awk available for just about any operating system you can think of. But although it's distributed so widely, heavy usage has mostly been replaced by Perl, which was actually developed around the same time as New Awk and was very heavily influenced by Awk, actually. So, enough of the history. Let's get to the language. Awk is, all in all, a very simple language. A program just consists of a set of rules, which are each composed of one pattern and one action. And this rule is applied to the input supplied. It's possible to omit either a pattern or an action from a rule, but not both. And if you think about that, it would be kind of pointless to omit both. Now, input in Awk's case can be a file or multiple files, or it could be a pipe from a previous command, if you're familiar with the shell pipeline syntax. Or it can be standard in, which is what you get if you don't supply another form of input. And standard in, of course, is generally your keyboard input to the terminal, so it'll run the program, meaning apply the program's rules, to your terminal input until you specify in the file with Control D or Control C or whatever it happens to be on your system. And Awk operates on the notion of records and fields. So you have a file with multiple records, and each record has multiple fields. And these are determined by a record separator and a field separator, which by default are a new line and white space, respectively. So what you get by default is a line of text is a record, and each word on that line is a field. You can specify your own separators to change that behavior, which we can touch on in a moment. Also, an awk program, which is a set of the awk rules, can be stored in a file and then loaded in a command rather than entering all of your actions in line. If you see the F option there on the command line, that's what will do it for you. Now, if you remember, an awk rule is made up of pattern and action. So a pattern is what ultimately controls execution in an awk program. If the input record matches the pattern, its action will run. If it doesn't match, the action doesn't run. Pretty simple. At a really basic level, it's kind of like an if statement that you're probably used to. If the expression evaluates, then the code block runs. If not, it doesn't. Now, a pattern can be an expression, basically a comparison expression. The pattern matches if the expression evaluates to non-zero, if it's a number, or non-null, if it's a string. It can also be a regular expression, which in my own experience has been the primary usage of awk. That's what I've used it for. It can also be two patterns, or subpatterns, that are separated by a comma. And when you go this route, you're matching a range of records between two patterns, meaning it includes records starting with and including the first record that matches the first pattern, and ending with and including the last record to match the second pattern. Then you can also give no pattern, in which case every record in the input will match, so your action will be run for every record in the input. Now there's also a pair of special patterns, uppercase begin and end. And what these do is allow your action to hook into either the beginning or the end of the program execution. So you can do startup or cleanup tasks, or if you want to print a nice message welcoming, before you start running records, you can do that. The GNU awk adds a couple more, begin file and end file. They give the same functionality, just for multiple file inputs. It performs these actions at the beginning and end of every file that's read. But like I said, this is for doc only, so you won't find them on any other implementation. Now for the second part, actions. An action is performed when its accompanying pattern is matched. So, like we said before, with the pattern being like an if statement, the action part of an awk rule is essentially the block of code that's inside that control. And it's even slightly more similar to that than the pattern is, because an action is built from one or more statements that are separated by either new lines or semicolons and are enclosed in curly braces. So pretty similar. These action statements can be expressions, in which case this means variable assignments, function calls, things of that nature. Not the same type of expressions as in patterns, obviously. They can also be control structures. Awk supports the common structures like if, for, while, and switch. And also adds in break and continue statements. There's also a next control that skips to the next record in an input. And for multiple file inputs, there's a next file control that will skip to the next file. You can also use compound statements, meaning multiple or nested blocks of statements inside those outermost braces, as long as you have those outermost braces there. There are also input and output statements, and last but not least, deletion statements, which are only for arrays, which we'll get to. Caveat now to the syntax for actions. Curly braces are required when an action is supplied, even if it's an empty action. And supplying an empty action is different from omitting an action, because omitting an action causes awk to revert to the default action, which is to print the entire current record. And an empty action does nothing at all. Shell variables. So this gets into the details a little bit more. Since awk programs are very commonly used as portions of bigger shell scripts, it would of course be vital that awk be able to access shell variables. And there's two ways that this can be done. The first way, which is considered the more common method, is to use the quoting conventions of the shell to strip a variable in. Bash, for example, will substitute the value of a variable if it's placed inside double quotes. So the example here shows that. You see how the double quotes and the single quotes meet, which awk will concatenate to form the full rule. This is fine when the task is simple, but you can imagine how difficult it could get to manage multiple instances of multiple shell variables. That's why awk provides a command line option, which allows awk variables to be defined from shell variables before the program itself is executed. The other difference you'll notice is how the variable is referenced in the pattern here. This is known as a computed or dynamic regular expression. The tilde symbol just means that it's checking the left operand, that's the current record, for a match to the right operand, which in this case is the regular expression. We've also got built-in variables in awk. Offers a lot of variables that a program can reference just to display information, and some others that can be manipulated to actually change awk's behavior. The more common informational variables are, and you see these are in all caps, NR, which contains the number of records processed since the beginning of execution. This count is updated at the end of processing of each record. NF, which contains the number of fields in the current record. File name, which is pretty self-explanatory. It has the name of the input file that's currently being processed. So if there's another input file after the current one, then that variable will be updated when the current file is done processing. And in familiar fashion, we get argv and argc, which contain the list and count, respectively, of the command line arguments that were supplied when the awk utility was called. Now, the most important, say, mutable awk variables are, again, you see there in all caps, fs, which is the field separator character. This is, by default, a white space character, a space, a tab, and that gives us the words as fields behavior. RS is the record separator character. Again, this is the new line by default, which gives us the lines as records behavior. So changing this or FS would change the processing behavior of awk completely. Then there are OFS and ORS, which are the output equivalents of FS and RS. The default for OFS is a space character, while ORS defaults to another line. Then finally, we have the O format, output format, which is the format used for numeric output from awk. The value for this should be something that you would use in a traditional printf function, and you can see the default value there. User variables can be defined in awk, provided their identifiers only contain valid characters, of course. Capital and lowercase letters, numbers, and the underscore character, just like most other programming languages. Awk doesn't have an operator for concatenation, so identifiers and string constants adjacent to one another will be automatically concatenated. Comments are also supported in awk. They start with a single pound sign, just like a shell script, and also similar to a shell script, there's not a delimiter for multi-line comments, so that symbol has to precede each line. Now here's a big one, user-defined functions. This is one of the greatest advancements that Nock, or new awk, or the one true awk introduced. User-defined functions, they have a very simple declaration syntax, very similar to C style, Java, all the same. And their call syntax is really simple too. But there's another syntax caveat here. There cannot be white space between a function's name and its opening parenthesis. Because of the lack of a concatenation operator, awk interprets that white space as the concatenation of a named variable and an expression that's in parentheses, so it'll give an error. And the last big thing is arrays, and it's a really great feature the way that they've implemented it. They can only be one-dimensional. Multi-dimensional arrays aren't supported, at least not yet. But awk uses the associative array concept, which carries a lot of advantages over the array constructs we're used to seeing in languages like C and Java. If you're at all familiar with the way arrays work in interpreted scripting languages like JavaScript and PHP, awk's array design seems to be very similar. Arrays in awk don't have a predetermined size, which means elements can be added or removed at will. And elements are removed via that deletion statement that we talked about earlier. In addition to this, the nature of these associative arrays allow for subscripts that can be any numbers or even strings, and the order of elements is fundamentally irrelevant because each index is coupled with its value directly. Along with arrays comes a fantastic keyword that I really wish more languages had, the in keyword. It pulls double duty depending on what control structure it's used in. If you use it in a for loop, it triggers iteration through all the elements of the array on its right, assigning each subscript in succession to the variable on its left. And if you use the same keyword in an if statement, it becomes a search mechanism, and it searches the array on the right for the value on the left, which is pretty versatile. All in all, awk may be a child of the old school, and Perl might have stolen a little bit of its market share in the text processing world, but I think it's still a very relevant language and utility, and I think this fact owes a lot to Brian Kernighan and to the Free Software Foundation, for the GNU implementation, for keeping their respective implementations modernized and consistently updating. But also to Awk's fundamental usefulness, I think, as a data-driven language. It takes a sometimes daunting task of text processing and just simplifies it a lot. And at the end of the day, I feel like that's what a genuinely good programming language exists for, creating a way to take a tough task and make it easier. Thank you.